So we may have a case where we've got multiple triangles based on what we've been given. So this I took directly off of the formula sheet that I gave you that was called triangles with a whole bunch of exclamation points. So if you'll notice, there are 4 distinct cases. So every case that we've done up until now has been one triangle. Well, there could be a case where there's 2 triangles. So we want to look and see what's going on to determine if there is 2 triangles, 1 triangle, a right triangle, or no triangle at all. So what we have first of all is we need to relabel these. So I was given beta and little b, and I was given c. Well, according to the instructions on the handy dandy cheat sheet that I gave you about triangles, I should relabel this as alpha and A, and this is going to be B. Okay, so all I've done is relabel for the purpose of making these comparisons up here. So I've just relabeled, so your completed ratio is going to be involving A's, and your side that does not have a completed angle is going to be your B. So I need to know what H is. H is the height of your triangle. So looking at this, making sure that your calculator is in degree mode, I need to do H equals B sine A. So I have H equals B, which is 11, times the sine of alpha, which is 54. So I have 11 sine 54, which gives me 8.899. So I have H equals 8.899. Okay. So I want to start comparing now. If A is less than H, I'm not going to have a triangle. Well, that's not the case that we have. Okay. So he's gone. Okay. If A equals H, then I have a right triangle. Well, that's not what I've got going on. Okay. If A is bigger than B, then I've got one triangle. So I've got A bigger than B. Well, that's not the case either. So let's look at this final case. H is smaller than A, which is smaller than B. So this is the case that I have. So what we're going to do is we're going to finish out this triangle, knowing that there's going to be 2 of them at the end. So we're going to go back to the original labeling where this is B, this is C, and this is beta. So all of my little erasing marks. All right, so now we know this. So we're going to go back in and we're going to use the law of sines to figure out what the remaining sides and angles are. So this, remember, is gamma. And this is going to be alpha, and this is going to be A. And I know what B and C are. So using my initial ratio, I have the sine of 54 over 9.21313. And that's going to be compared to the ratio of the sine of gamma over 11. And I'm going to cross multiply. So I have 11 sine 54 equals 9.21313 sine of gamma. And then I'm going to divide both sides by 9.21313. 9.21313, and that is going to give me, divided by 9.21313, 0.96592. So 0.965924386, and that's what the sine of gamma is. Well, I don't want the sine of gamma, I want gamma. So I'm going to take the arc sine of both sides. So I have the arc sine of both sides, which means gamma is going to pop out. So the arc sine of that answer is 74 or 75 degrees. 75 degrees. So we just found out that this, sorry, that went kind of fast. Okay, so you can see everything I just did. So that means that gamma is 75 degrees, where I'm going to go ahead and build a second triangle right now using this information right here. So I'm going to have the exact same triangle, and this is not going to be drawn to scale at all, so don't let the scale freak you out. And that means I've got a C of 11. I know that this is 54, And I know that this is 9.21313. Well, this, while ago, I found out is 75 degrees. Okay, well, it's not going to be 75 degrees anymore. I'm going to take whatever I found right here, and I'm going to find that second case for a triangle by subtracting this from 180. So 180 minus 75 is going to be 105. So now I've got another triangle that I can set up. Okay, so I've got a completed ratio. I've actually got two completed ratios, which means if this is 54 and this is 105, I can figure out what this is. However, I'm going to interrupt myself. I'm going to come back and finish my initial triangle first. So I've got 105 minus 54 gives me 51. So that must be 51. And I'm going to let you finish this. Actually, I'll just go ahead and finish it. I don't have much room, but we'll finish it. So I've got the sine of 75. I just broke my own rule. Never, ever, ever go back to the rounded values. Always go back to the values that you were given. So 9.21313 is going to equal, what am I missing? The sine of 51 over little a. Okay, so I got this from my initial values equals the sine of 51 over a. Multiply or cross multiply, so I get a times the sine of 54 is 9 point. This is why I didn't want to do it. Sine beta, which is 51. So this will be the sine of, dadgummit, 51 I said. 51. Okay. So I've got a sine 54 equals 9.21313 times the sine of 51. That's times. I'm not dividing. I just ran out of room. So now I'm going to divide both sides by the sine of 54. So I have a equals 9.21313 times the sine of 51 over the sine of 54. And that is going to give me 1 second, 1313 times the sine of 51 divided by the sine of 54 gives me basically 8.85. Okay, so that is what this side length is, 8.8502. 8.8502. Okay, so let's go back to the triangle we haven't finished yet. So let's review again. Where did the 105 come from? I used the law of sines to figure out that the peak of my triangle was 75. How did I get the 105? I subtracted it from 180. So I now have two completed ratios, almost a third one. I just need to figure out what this angle measure is. So 180 minus 105 minus 54 gives me 21. Okay, so I can use the law of sines going back to my original values. So the sine of 54 over 9.21313 equals the sine of 21 over little a, because this is alpha, this is gamma, and this is beta. Okay, so I'm going to cross multiply. A times the sine of 54 equals 9.21313 times the sine of 21. Divide both sides by the sine of 54. And I will get A equals, let's figure out what that is. And I get 4.08111. So that's how we handle an ambiguous case. So I want to go ahead and do the next word problem, or actually a word problem. We got Frank and Marie and they're sailing. So here's Marie, here's Frank. After 3 hours, Marie and Frank are 4 miles apart. We know that Frank is sailing 7 south 7 degrees east, and that Marie is sailing south 12 degrees west. So what does that mean really quick? If I have a bearing, the first letter is where you start. So I'm going to start south. The second is how far you swing out. So I'm going to swing out 7 degrees. The third is where I swing to. So I'm going to swing out to the east 7 degrees. Okay. So for Marie was south 12 degrees west. So that means I'm going to start south. I'm going to swing out 12 degrees to the west. So that's how we handle bearings. So I want to figure out how far Marie sailed. So by doing that, I almost have a completed ratio. Okay, if I knew what this angle was, I'm trying to find out the distance from here to here. So looking at it that way, what I have is I can figure out what this triangle is because that's 90 degrees and this is 90 degrees. So 90 minus 12 is going to be 78. 90 minus 7 is going to be 83. Okay. So I know this big triangle now is what I'm concentrating on. I know that these two angles added together are 19 degrees, and I'm trying to find this side length right here. So I can do the sine of 19 degrees over 4 must be the sine of 83 degrees over the length of Marie's sailing distance. So I just used the big triangle in this case. So I have m times the sine of 19 equals 4 times the sine of 83. And divide both sides by sine 19. And I have Marie's distance that she sailed is 4 times the sine of 83 divided by the sine of 19. And I get 12.1946. So that is how many miles Marie has sailed. So look at the bigger triangle and then do the law of sines from there. And I'll pick up the next ones in another video.